Welcome to Lesson 15, the moment we stop talking about networks in the abstract and walk straight into the closet. You already know from Lesson 8 what a modem, router, switch, and access point do in concept. Now we're putting hands on the hardware. Each box does one job. And by the end of this lesson, you'll stand in front of any rack and name every device, its role, and whether those blinking green lights mean healthy or broken. Let's start with the box you'll see most often, the switch. It's that flat unit with 8, 24, or 48 ports, and it operates at layer 2, meaning it speaks MAC addresses, not IPs. The clever part, it learns. The first packet from any device teaches the switch which MAC lives on, which port, and from then on, traffic goes only where it needs to. Add gigabit speeds, power over Ethernet for your phones and access points, and VLANs to slice one physical switch into separate virtual networks. And you've got the workhorse of every office closet. Now step up one layer to the router. Where the switch moves frames between devices on the same LAN, the router moves packets between entirely separate networks, your home LAN to your ISP to the wider internet. It works at layer 3, reading the destination IP and consulting a routing table that says, in effect, for this network, send the packet out that interface toward that next hop. When nothing in the table matches, it falls back to the default gateway, the 0.0.000 route that points upstream. And in almost every home and small office, the router also runs NAT, rewriting your private IPs onto a single public one so a dozen devices can share one address. So let's put it all together physically. Walk into any office network closet, and you'll see this same stack, top to bottom. The ISP modem where fiber or coax from outside terminates into Ethernet. That's your WAN side. Below it, the router joining your LAN to the ISP. Then the switch, where every wired device in the building lands. And cabled out from the switch, the ceiling APs broadcasting Wi-Fi. Cables flow downward. Lights blink green when traffic moves. One job per box. That's the whole map. Now zoom in on those ceiling APs we just mentioned. An access point is really a translator with two faces. One Ethernet port on the back that uplinks into the switch, usually powered right over that same cable through PoE. No wall wart needed. And on the other side, a radio broadcasting SSIDs on 2.4, 5, or sometimes 6 gigahertz. In a small office, you might configure 2 or 3 APs by hand through their web UI. In a big office, you don't. You let a controller like Cisco, WLC, Aruba, or Unify push one config to all 20 of them. And rule of thumb for coverage, 1 AP per 30 square meters, more if the walls are concrete. Now step back to the switch itself and just look at it. Every port has a tiny LED, and that LED is doing free diagnostics for you. Solid green means the link is up. Walk away. Blinking green is actual traffic flowing. Totally normal. Amber is the one to catch. The link came up, but at a lower speed than it should, usually a tired cable or a misconfigured NECI. And dark. Something's dead. Reseat the cable, swap it, try another port. On the cabling side, Cat5e handles 99% of desktops. Cat6 goes on servers and uplinks, and fiber with that little LC connector is reserved for the long runs between switches. Now let's put all of that to work. 4 scenarios, the kind you'll actually walk into. 1. User says Ethernet is dead. Port LED is off. Reseat, swap cable, swap port, and if it's still dark, the NIC inside their PC is the suspect. 2. Amber light. Cable can't keep up. Upgrade Cat5 to Cat6. 3. Wi-Fi dead in one room. Trace it back from the switch port to AP power to the controller. And 4. Whole office down. Work top down. Modem, router, switch, and find which one went dark first. Before we wrap, lock in the language. These 12 terms are what you'll hear on every ticket, every data sheet, every conversation with a senior engineer. Switch and router you know. Layer 2 versus Layer 3. Modem is the ISP's box. AP is the wireless bridge. Uplink is the port that climbs to the next device up. PoE carries power and data on one cable, SFP is that pluggable fiber module, and the MAC table is the switch's self-built map of who lives on which port. Speak this vocabulary fluently, and you sound like you belong in the closet. Now let's clear up 5 myths that burn hours on real tickets. Switch and router are not the same. One glues a LAN together at layer 2, the other bridges networks at layer 3. The home combo box is what confuses people. Ethernet cable isn't just Ethernet. An old Cat5 will quietly cap your gigabit link at 100 megabits. More APs doesn't mean better Wi-Fi. Overlapping channels fight each other. A green light only proves a link exists, not that it's running at full speed. And not every switch is unmanaged. Try configuring VLANs on a $20 plug-and-play box and you'll lose an afternoon. And that's lesson 15 in the bag. You've got the closet locked in. Switch is your LAN glue at layer 2. Router stitches networks together at layer 3. The AP is your wireless edge. And the lights on the front will tell you most of what you need to know before you even open a terminal. Next up, lesson 16, Wi-Fi standards. 802.11. A through B, the 2.4, 5, and 6 gigahertz bands, and when to reach for which. Finish that one, and the stage 2 capstone is waiting. See you there.